over 3.3. How much? 28? Yeah. 28 meters per second. We got this. We got this. Now we want to find B final. Yes?
Are we looking for VO is at the beginning, right?
At the beginning.
But at the beginning is x equals 9.
X equal?
Is x equal 90?
No. X final is 90. XO is 0. We are looking for VXO, the velocity along X. This is 90. X is 90.
I thought we were looking for the components of
the velocity.
Initial.
Yes, of the initial velocity.
So we're looking for the x component of V initial. So
yes.
So we're using, I thought we were using the x component, and the x component of V initial, is it 9? I'm going to teach 9.
What is 90? The distance traveled on the x-axis. Distance travel or position travel. This distance is 90. The velocity is a different thing. How fast is impacting? And it's moving like this at the point of impact. Look, like this means that it has a component along X, along Y, and along X, which is here. Can you see? That this component, and what we know is that this component will be the same than this one. Why? We know that this component along X will be the same than the one along X at the beginning. Because acceleration along X is constant, and there is a thing here, because the acceleration is 0, that Vx is equal to Vxo. So, we are looking now for Vxo, but we found that Vxo is the same than Vo. So, which will be 28 meters per second. How much is Vyo? 0. Now, the next question. I asked for the velocity vector. How can you write the velocity vector? Either by components, by magnitude and direction, or by IJK notation, which in this case will be what kind of a notation? I and J. These are the three ways of writing the vector. So what we need to find in order to find V at the end, either the X and Y component or magnitude and direction. But in order to find the magnitude and direction, I need to find the rectangular components first. How can I find Vx? See, in order to find V, I need to find Vx and Vy. This is velocity vector. Or I can write like this if I want. How can I find Vx? Look at the concept. What said the concept about Vx? Vx is equal to Vxo. How much is Vxo? 28? So 28. Vx is equal to Vxo, never change. The x component of the velocity never change. So Vx is equal to Vxo. How much is Vy? How can I find Vy? Don't tell me 0 anymore. Vy is only 0 at the maximum height. That is not the maximum height. How can I find it? Everything in physics is finding with formula. There is no such a thing like David Copperfield, right? The magician or whatever. No. In physics there is no magic. Magic is use the formula. Tell me what formula we can use to find Vy. The first one. You have the time? Yes, we have the time. So if we have the time, we can use the first equation to find this Vy. Do you have Vyo? How much?
0.
Do you have Ay? Negative 9.8. Do you have the time at the point of impact? How much? 3.3 seconds. Can you find it? Yes. Don't tell me 0. Don't tell me no. Leave that for the people there in Havana. You know, no. Here in ASA, it's physics. All right. Vy is equal to Vyo minus or plus Ay t, which is the same than 0, because it's moving horizontally, and you know that BYO is 0, minus 9.8 or 10, if we use 10, times 3.3. How much will be BY? Negative 33 meters per second. Is logic the negative 33? Is going up or down at that moment? So, can you see that this velocity, the Vx, this is the same than this one. But this is positive or negative. Can you see that it's negative? Negative 33 meters per second. It started at 0, but the gravity is pulling down, and pulling down, and pulling down, and moving faster down, negative 3, when touch the ground. Okay, this is the way that we solve a projectile motion problem. Any question? Needs practice. For this reason, I consider that the two problems you have here, you have also online, on the online homework. But I know that some people will leave the online homework for, you know, with the turkey. And, you know, so, but there is practice there. In online, in the master in physics, I put several problems of projectile motion. I hear in the study guide you only have 2. That is not enough. I will print the paper with a little bit more practice of that. The multiple choice, for projectile motion. All right, so this is when the object is moving horizontally. The problem or the picture that I showed you there was moving like this. So this type of motion will be the second type of motion. And the second type of motion is when you throw from the ground to the ground, which is the same. This and this, what is the difference between this and this? The initial height is different from 0, number 1. 2, the path is symmetric. What is the meaning that the path is symmetric? The same time will take to go up than to go down. That's great. Because if you get the time at the maximum height, then you multiply by 2 and we get the total time, which you cannot do it in the other problem. The velocity initial and final, the speed, are the same. And the y component only are different, that at the beginning is positive and at the end negative. And the x component of the velocity is the same. That's it. So it's simpler than the other one, but they are pretty much about the same. And we treat in the same way. So for instance, the problem that we have there, an object is thrown with a velocity VO 40 meters per second. And the time, and the angle, 37 degrees. The equation, A, find the time of travel. B, find maximum height. C, actually, let me just go by step. Find the range. What is the range? The maximum